Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is sum of k-mirror numbers. Now, the problem category is of hard level, but I would say after watching this video and understanding the problem and the solution approach, you are going to find this particular problem easy to solve. Now, the input given in the problem are two integers, integer k, another integer n. The output which we need in this particular problem is the sum of n smallest k-mirror numbers. Now, this n is given in the input and this k is given in the input as well. We need to find out the smallest k-mirror numbers, n smallest k-mirror numbers, and take the sum of it, and then we can return it as an output. Now, you might be asking that what is a k-mirror number? Like what number can be called as a k-mirror? So k-mirror numbers are having these four properties. First of all, it will be a positive integer. For example, 1, 2, 3 up to infinite, all are positive integers, right? 0 is not a positive integer. -1, -2, -3, these are not positive integers. So k-mirror number, the first point is, should be a positive integer which has no leading zeros. So a k-mirror number should be a positive integer, should not have a leading zero, and the number is a palindrome with a base of 10. Now what is a palindrome and what is the base of 10? Let me tell you. When we talk about palindrome, it means that if you reverse the number, both the numbers, the original one and the reversed one, will be equal. For example, 121. If you reverse this number, 1 will be written first, then 2, then 1, right? Now, this is the original number 121. This is the reversed number which is also 121. So it is a palindrome number. One more example is 25352. This is also a palindrome number because if you reverse it, 2, then 5, then 3, then 5, then 2. Both these numbers are equal. So this number is also a palindrome number. So a base 10 number is a normal decimal number, right? Like 1, 2, 3, 4, 5, 9, 15, 29. All these numbers are base 10 numbers, right? So the basic decimal numbers are the base 10 numbers. When we say base 10, it means it is made up of 10 different digits. 0, 1, 2, up to 9. So these are the digits included in the base 10 number. Now these are the 3 points. There is one more important point which is very important, that the base k of that number is also palindrome. For example, if I talk about 121, is this a k-mirror number? Yes, it is a positive integer. Yes, it has no leading zeros. And yes, the number in base 10 is palindrome. Base 10 means it is a decimal number. So this number is right now a decimal number and it is a palindrome. Now the fourth point is the base k of that number is also palindrome. Here, the value of k is important. The value of k can be 2, 3, up to 9. Starting from 2 up to 9. It's given in the problem itself, the constraint. Now let us say the value of k is 2. It means that if you want that 121 is a mirror number, a k mirror number or not, then these 3 points are fine. Check the fourth point. Is the base 2 of that number is also a palindrome? Now a base 2 is nothing but a binary number, right? In a binary number, there are just two numbers, 0 and 1. So when we say base 2, it means it has total two different digits, 0 and 1. Now convert 121 into a binary number, and if this binary number is also a palindrome number, then you can say 121 is a k-mirror number. So I hope this clarifies that what is a k-mirror number. Now you need to understand again that the input is an integer k, another integer n. Give the output as the sum of n smallest k-mirror numbers. So try to find out the first n k-mirror numbers, take the sum of it and return it as an output. That's it what we need to do. Now let's try to understand it with some examples. In the example number 1, the value of k is 2, n is 5. Now if I ask you what is the output we need, then you will have to answer that we need to find the sum of first 5 numbers for which the base 10 of that number and base k of that number is also a palindrome. Because these are the properties of k-mirror numbers. The base 10 of that number and base k of that number is a palindrome. Then we can say that this is a k-mirror number. Of course, the number should be positive integer without a leading zero. Now you might be confused that the question says find the n smallest. You are saying find the first 5 numbers. So basically the smallest numbers comes first, right? That's why I'm saying find the sum of first 5 numbers, first n numbers for which base 10 and base 2, because the value of k is 2, the base 2 of that number is a palindrome and the base 10 of that number is a palindrome. Okay, let's try to do it. Let's try to find the first 5 numbers. So the first 5 numbers are going to be 1, 3, 5, 7 and 9. Basically 1, 3, 5, 7, 9 are the base 10 numbers. These are basic decimal digits or numbers we have. And the base 2 conversion of these numbers are 1, 1, 1, 101, 111 and 1001 for 9. Now you can see that all these numbers are palindrome. All these numbers are palindrome. Basically you can reverse 1. The reverse of 1 is also 1. Reverse of 3 is 3. Reverse of 5 is 5. Reverse of 7 is 7. Reverse of 9 is 9. So we can say these are palindrome. Also for these numbers, if you will notice, if you try to reverse these numbers, let's say this one. So reverse of 101 is 101. Reverse of 1001 is 1001. So yes, we can say all these numbers are also palindrome. So we found out the first 5 smallest k-mirror numbers. we can just take the sum of all these 5 numbers, 1 plus 3 plus 5 plus 7 plus 9, 25. Now let us see one example of a smaller number which is not k-mirror. For example, you might say between 1 and 3, 2 is also there. Now 2 is a base 10 number and the base 2 of 2 is 1, 0. Basically the binary representation of this number. But this 2 is not a k-mirror number because although it is a positive number, although it doesn't have any leading 0 and it is a palindrome number in base 10, but when we convert it to a base k format where the value of k is 2, so the base 2 format 1, 0, this is not palindrome because if you will reverse it, it will be 0, 1, which is not equal to 1, 0. That is why although the number 2 is smaller, it is not a k-mirror number, so we are not including this in our first 5 numbers. Now let us see one more example where the value of k is 3, the value of n is 7. In this case, you need to find out the first 7 numbers for which the base 10 and base 3, this 3 is coming from here, is a palindrome. So the numbers are 1, 2, 4, 8, 121, 151 and 212. These are the smallest 7 numbers which are palindrome and whose base 3 is also palindrome. The base 3 of 1 is 1, base 3 of 2 is 2, for 4 it is 1, 1, for 8 it is 2, 2, for 121 it is 1, 1, 1, 1, 1, for 151 it is 1, 2, 1, 2, 1, for 212 it is 2, 1, 2, 1, 2. Now base 3 means it can have 3 different digits, 0, 1 and 2. So you will notice all these numbers are made up of 0, 1 or 2, none other than this, right? Now I will tell you how to convert a number into base 3, base 4, base 5. I will tell you. For now, for this example, k equal to 3, n equal to 7, the output is going to be 499. That's the sum of all the first 7 numbers which are k-mirror numbers. Okay, let's try to understand about what is a base k numbers because that's very important to understand. This question is all about this base k numbers, right? So a base k number are those numbers which are represented with k different digits. For example, if I say base 10, now what is a base 10 number? These are normal decimal numbers we know about, right? In decimal numbers, there are total 10 different digits, 0, 1, 2, up to 9. We have 10 different digits in a decimal number and that is why it is called as a base 10 number. So a base k number are the numbers which are represented with k different digits. When we say base 2, it means it will have 2 different digits, 0 and 1. Base 3 will have 0, 1, 2. Base 7 will have 0, 1, 2, 3, 4, 5 and 6. Now, since the digits are starting with 0, the last or the highest digit is always going to be less than k. That is less than 7, 6, less than 3, 2, less than 2, 1. Even for base 10, the highest digit itself is 9, right? All the numbers are made with the highest digit 9, starting from the smallest digit 0. Now let's try to understand how can we convert a base 10 number to a base k number. So let us say the base 10 number is 68. Now this is a normal number, normal decimal number. If you want to convert this to a base 7 number, the process is very simple. Just take the mod of 68 with 7. So 68 mod 7 is 5, right? Now, once you calculated the mod, you divide the number 68 with 7. 68 divided by 7 will be 9. I mean this will be 9 point something, right? Because 7 multiplied by 9 is 63, 7 multiplied by 10 is 70. So 68 is between this, right? So 68 divided by 7 is going to be 9 point something. But the thing is, we already calculated the remainder part. This part, we already know about it. So you don't need to worry about the decimal part, okay? So 68 divided by 7 will be 9. Now do the process again. 9 mod 7 is equal to 2, right? Now divide 9 by 7, this will be 1. Now 1 mod 7 is equal to 1. Now divide this 1 by 7 and the moment your current number becomes 0, it was 68, then 9, then 1 and now 0, you can stop. Now tell me what are the remainders you have got after taking the mod. So it was 5, 2 and 1. So take the number in reverse, 1, 2 and 5, 125. This is going to be the base 7 of your base 10 number 68. So when you want to convert the base 10 number 68 to a base 7 number, it will be 125. And now you will notice that this number 125 is made up of digits 1, 2 and 5. We know that base 7 numbers are 0, 1, 2, 3, 4, 5, 6. No 7, no 8, no 9. So our number 125 is made up of 1, 2 and 5. Now one of the logic, how can you think about this is, see the thing is, I want to convert my number into some other number, right? Like 125. Some other number should only be made up of 0, 1, 2, 3, 4, 5 and 6. If you take a mod of any number with some other number, let us say 7, then the output cannot be more than or equal to 7. It will always be less than 7. If you take the mod of any number with any other number, let us say k, then the output will always be less than k, right? And that is what we need to find out in a base k number, because a base k number is made up of all the digits which are smaller than k. So for base 7, the digits are up to 6. For base 3, the digits are up to 2. And that is why we take the mod, this is what we get, then divide the number, okay, it is not 0, take the mod again, divide the number, okay, it is also not 0, take the mod again, and now once you divide it by 7 again, it is 0, you can stop. Let us take one more example, and this is what we are going to do a little bit quickly. Let us try to convert our number 68 to a base 2 number, or I can say a binary number. It is made up of 1 and 0. In this case, you can say, okay, I'll just first take the mod of 68, which is 0, then divide 68 by 2, and then we can divide 68 by 2. This will be 34. 34 mod 2 is 0 again. Divide 34 by 2, it is 17. 17 mod 2 is 1. Divide 17 by 2, it will be 8. 8 mod 2 is 0. Divide 8 by 2, it is 4. Now, 4 mod 2 is 0. Divide 4 by 2, it is 2. 2 mod 2 is 0. Divide 2 by 2, it is 1. Now, 1 mod 2 is 1. And now, once you divide 1 by 2, it will be 0. So, now you can stop, right? And now, you can just take the number in reverse. Take all the remainders you have got in reverse. So, it will be 1, then 0, then 0, then 0, then 1, then 0, and then this 0. Okay, let me write this 0. Now, this number is the binary representation of 68. 68 is a base 10 number. This is a base 2 number. Now, let's try to focus on the solution approach. Now, we know that how to find a number, how to convert a number to a base k number, right? Now, we will focus completely on the solution approach, and we are first going to do it in a brute force method. And then we will try to optimize this particular approach, and we will also understand what's the thought process, how can you think about the solution. First of all, we are going to create two variables, result, which will be 0, and count, which will be 0. Now, this result variable is going to store the answer, that is the sum of first n k mirror numbers, and the count is going to store how many numbers have we found at a particular time in the code. We need to find n k mirror numbers. As of now, we have 0, right? We will search for k mirror numbers, and once we find a number, we will make it 1. Then we will search for the second, then the third. So we basically need to search for the n smallest k mirror numbers, and this is the count. This is going to store how many have we found at a particular time. Now we can start from 1, that's the smallest positive number, and keep going to infinite. I mean, if we want to find out n numbers, we don't know what's the range, right? So we will have to search from 1, and we need to keep going. We don't know the end, right? So let us say we are going till infinite to find the first n numbers. We need to find all those numbers inside this range which are palindrome and whose base k is also a palindrome. And the moment we find a number, we will say, okay, result plus that number, and count will be plus 1. Then we will find another number, and we will say result is equal to result plus another number, let's say num2, and then we will say count is 2. We found 2 numbers. Our goal is to find n numbers. N can be 1, 2, 3, 4, up to 30 according to the question. But here's the problem. There is a very big problem with this approach. This is a brute force approach. Just keep going from 1 to infinite. Check for each number if they are palindrome, convert it to a base k number, and check if it is also a palindrome, right? And if it is, you can just add it to the result, and you can say count plus 1. This is brute force. We have to go from 1 to infinite. We don't even know that up to what number we will have to run the loop. So this end number can be very, very large, and this can throw time limit exceeded error. So the thing is, our search space is from 1 to infinite. Our search space is very large. We need to optimize this search space, right? We know the problem. So we will have to think about something which can optimize this search space, right? From 1 to infinite, let's try to reduce this space. So the process is, right now we are checking all numbers for palindrome. And if yes, if we found a number which is a palindrome, we convert the number to a base k, check if this converted number is also a palindrome. If yes, add it to the result and increase the count of numbers we found. But the thing is, this particular approach or this particular area is where we can do the optimization. And why so? Because this is our problematic area. Here we are searching for all the numbers. If we are searching for all the numbers, time limit exceeded will definitely be there. Now I'm asking you guys, how can you think about something which can optimize this searching space? So there is one thing which comes in our mind. What is the thing which you want from this particular space? You want the palindrome numbers, right? The numbers whose reverse are the same. So why should I check for all the numbers from 1, then 2, then 3, then 100, then 101, 102, 587, 588, up to infinite. I don't know up to what number I have to check. But why should I check for all the numbers? Why can't I just create the palindrome numbers? Why can't I start creating the smallest palindrome numbers? And once I have the numbers which are palindrome, I can convert the number to a base k and check if that converted number is a palindrome or not. Now in this case, the thing is, this particular space is reduced from 1 to 9. I will have 9 palindrome numbers. All are palindromic numbers. From 10 to 99, I think we have some limited set of palindrome numbers. We have, I think 10 or 11, I don't know, but 10 or 11 are the palindrome numbers. There are total 10 or 11 palindrome numbers. From 100 to 999, there will be, let's say, 100 palindrome numbers. But here you will see that from the range of 1 to 999, I have 1000 numbers, right? Or I think 999 numbers. But the total number of palindrome numbers are around, let's say, 130. So out of 999 numbers, there are just 130 numbers which are palindrome. So we will have to check for just 130 numbers in the range of 1 to 999. Similarly, if this range is increasing, right now we are checking up to infinite. So if this range is up to infinite, or let's say it's very large, let's say we are going till 10 is to power 10. So we will have to check for all these numbers. Are they palindrome? And if yes, then we will have to convert to base k. and then we will have to check again for the palindrome of that converted number. Instead of that, instead of checking for all these numbers, just check for, let's say, up to this range. Let us say we have 10 is to power 3 palindromic numbers, or let's say 10 is to power 5. Still our search space is reduced from 10 is to power 10 to 10 is to power 5, right? So we will just have to check for 10 is to power 5 palindromic numbers. I mean, that is the idea of this particular solution. Instead of checking for all the numbers, check for only palindromic numbers. Try to create the palindrome numbers, and then you convert that number to base k and check if the converted number is a palindrome number or not. So now our goal is to generate palindrome numbers. Now the thing is, palindrome number can be odd or even length numbers. For example, odd length palindrome numbers are 121, 9, 2, 3, 1, 3, 2. I mean, these are some examples. If you try to reverse these numbers, they will be equal to the same number. In even length palindrome numbers, it is 1, 2, 2, 1, 1, 1, 2, 4, 5, 5, 4, 2. These are some even length palindrome numbers. Now the thing is, in odd length and in even length palindrome numbers, there is a thing which you should notice. You will see that in even length palindrome numbers, for example, if it is 1, 2, 2, 1, then you will see 2, 1, 1, 1, right? The first half of the number and the second half of the number is the reverse of it. The first half is 1, 2, the second half is 2, 1, reverse of 1, 2. In the second number also, the first half is 1, the second half is reverse of 1, which is 1, 1. In this one, you will notice that the half part 245 and the other part 542 are just the reverse of each other. 245 and 542, 542, right? So this is what an even length palindrome is. In the odd length palindrome, it is a bit different. The middle character can be changed and it will not affect the number being a palindrome or not. For example, in 121, the half part is 12, right? 1, 2. Or you might say the half part is 1. Now this is a question of debate, that do you want this to be half or this to be half? Fine. Let's not worry about the mid part. Let's forget about it. Now you will say this is the half, 1. The reverse of it is 1. 121 is a palindrome number. The middle part, 2, can be 3, can be 4, can be 9, can be any other number, and still this will be a palindrome. 121 or 131 or 141, all are going to be palindrome. Similarly, in this number 9, the middle part is 9, right? If you forget about the mid part, then you don't have any other number. So this is a palindrome number. Now this mid part can be changed to 9 or 8 or 7 or 6. So a 1-digit number is always a palindrome number. What about a 5-digit odd length palindrome number? Again, you can keep this middle number or you can forget the middle number. Now you take the half, which is 23. Its reverse is 32. 3 is here, 2 is here. So this is a palindrome number. So the main difference is, in odd length palindrome number, you don't worry about the middle part, right? Now, since we need to generate small palindrome number first, what we are going to do is, our logic will be to generate the 1-digit palindrome number first, then 2-digit palindrome number, then 3, then 4, then 5, then 10, 20, 30, whatever. But our logic will be to generate the 1, 2, 3 small digit palindrome number first, because we need to generate a smaller palindrome number first, right? So we will do it digit by digit. Now the next thing is, for each of the different length, for example, length 1, length 2, length 3, 4, whatever is the length, we need to generate the half length number first. And that's because I already told you, in a palindrome number, the half part is a number and the other part is the reverse of the same number, right? The half is a number and the other is the reverse of that half part, right? In the odd, if you forget about the mid part, this is going to be, again, half is here, half is here, half is here, half is the reverse of it. So that is why what we are going to do is, to generate any length palindrome number, we are going to generate the half length number first. Now this half length number is going to be our first half of our palindrome number. Then we can just mirror or reverse this first half, and then we can add this reversed part to the first half to form a full palindrome. For example, 121. If you want to form a palindrome number, and if this is your half part, reverse this, the reverse of it is also 121. Now this whole number itself is a palindrome number. Or maybe 28. Take the reverse of it, 82. Add it to your original number, 28, 82 is 2882. This is also a palindrome number. Now this is even length palindrome number. What if you have to generate a odd length palindrome number? For example, if your half part is 282. Now if you want to generate the odd length palindrome number, then you will not worry about the last digit. Just worry about all the digits but not the last one. Take the reverse of it, this will be 82. So this can be a palindrome number of odd length created from 282, where the middle character can be anything, right? As I told you, in odd length it can be anything. Right now it is 2. So our number is 28282. This is a palindrome number. So this is our logic to generate palindrome numbers. Let's try to generate length 1, then we will generate for length 2, then for length 3. For all these 3 different lengths, so for 1, 2, 3, these 3 lengths we will try to generate to see how do we generate the palindrome numbers. And once we have a palindrome number, let's say any number we have, our logic will be simple. We convert this number to a base k number. Now this converted number, we will check if this number is a palindrome or not. And if this is a palindrome, then this number can be chosen as a k mirror number. So our whole idea of solving this question is behind generating the palindrome numbers. So let's do it. How about generating length 1 palindrome number? So length 1 palindrome numbers are 1, 2, 3, 4 up to 9. All are palindrome. Fine. Let's see the logic. Take the half length. Now If the length is 1, the half length is going to be 0.5, right? Now the thing is, again you might question that if it is 0.5, will the half length be 0 or 1? I would say go for the higher side. That's because, let us say if it is 1, 2, and you want to generate the odd length palindrome number, then you don't need to worry about this digit. That's the last digit you have. Just take the reverse of this, put it here. 121 is your palindrome number, odd length palindrome number. To generate 121, which is a 3-digit palindrome number, you need 1, 2. That is a 2-digit number. That is why we are going in the higher side. The half length of 1 is 0.5, right? We will say, okay, let's say the half length is 1. So the formula is going to be, to find the half length, we will say length plus 1 divided by 2. 1 plus 1 divided by 2 will be 2 by 2, which is 1. So the half length is 1. Now our searching space will be all the 1-digit numbers, 1, 2, up to 9. This is our search space, and I will tell you how to find the search space. Our search space is 1 to 9. The formula for this is, our starting point is 10 is to power half length minus 1. Now half length is 1, minus 1 will be 0. So 10 is to power 0 will be 1. We will start from 1 and we will go up to 9, right? This 9 will be coming from the formula 10 is to power half length minus 1. Now it is very important to understand. The starting is 10 is to power half length minus 1. Here you will have to take half length minus 1, then 10 is to power that particular value. Here you will have to find 10 is to power half length, then minus 1. So 10 is to power 1 is 10, minus 1 is 9. Go from 1 to 9. Now this search space is just your half data. You might be confused, maybe for this particular length, length 1. We will see for length 2, length 3, then everything is going to be clear. So right now our search space is the half length we have from 1 to 9. What we are going to do is, we are going to loop from 1 to 9. Our numbers are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. If let's say your number is 123, right now the numbers are 1 to 9. Let's say the loop is from 100 to 999. Then you will have to process for this value as well, 123. Now, if your half length is 123, and if I tell you to create an even length palindrome, then you need to focus on this part. If your number is 123, the even length palindrome is going to be the complete reverse of your half data. 3 will be here, 2 will be here, 1 will be here. 123, 321, right? Now this is a palindrome number. You are able to create a 6-digit palindrome number using a 3-digit number, right? Now the thing is, this is the even length palindrome number. In odd length palindrome number, what you will have to do is, if this is your half length, don't worry about the last digit. Just worry about the digits before the last digit. Take the reverse of it. So reverse of 12 is 21. So this is 12, this is the reverse 21, and this is the middle digit. It was the last one. Now it is the middle one in the palindrome number 1, 2, 3, 2, 1. So in case the length you want is odd, you will have to forget about the last digit. Take the reverse of other digits. So in case the numbers are from 1 to 9, the last digit itself is 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't worry about the last digit, but before this you don't have anything, right? So you have nothing, the reverse of it will be nothing. So the palindrome number, when the half is 1, 2, 3 up to 9, will be 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all the palindrome numbers of length 1. Fine, let's focus on the length 2. A lot of things are going to be clear. For length 2, the different palindrome numbers are 11, 22, 33, 44 up to 99. What's the half length? The half length formula is length plus 1 divided by 2. Length is 2 plus 1 is 3 divided by 2. 3 by 2 will be 1.5. You can say it is 1. Okay. Now, what is the range of the numbers you are going to search for? It will be 10 is to power 1 minus 1, the starting range, 10 is to power 0, that is 1. Ending range is 10 is to power 1 minus 1, which is 10 minus 1, which is 9. We are again going to loop from 1 to 9. This is what we did from 1 to 9. But to find the length 1, the process is different because that is odd. To find for length 2, the process is different because this is even. When the number is even, for example 4, just take the complete reverse of your number. This will be 4. You can concatenate these two numbers. 4 and 4 will be 44. That's the palindrome number you need. So starting from 1, it will be reverse of 1 is 1. So 1, 1 is your palindrome number. Then for 2, it will be 2, 2. For 3, it will be 3, 3. Up to 9, this will be 9, 9. Now for length 3, let's see for length 3 as well. In length 3, there are many palindrome numbers. So I'm just going to take few examples like 111, 121, 131, 484. These are palindrome numbers. Again, the process is going to be same. Take the half of it. The length is 3 plus 1 will be 4. 4 divided by 2 is 2. The half length is going to be 2. Now find the starting and ending range. Again, the same simple formula is find all the numbers which are 2 digit, 10 to 99, right? The formula is 10 is to power 2 minus 1, which is 10 is to power 1, which is 10. Start, that's the starting range. Then 10 is to power 2 minus 1. So 10 is to power 2 is 100, minus 1 is 99. That's the ending. So our numbers are 10, 11, 12 up to 99. So these are our numbers, right? You need to generate 3-digit palindrome numbers. 3 is odd, right? In case the number is odd, don't worry about the last digit. Don't worry about 0, 1, 2, or let us say one example is 57. Don't worry about 7. Apart from it, whatever is the number, just take the reverse of it. Okay, I will not worry about this. The reverse of 1 is 1. The reverse of 1 is 1. For 1 it is 1. For reverse of 5 is 5. Reverse of 9 is 9. Alright, These are the reverse. Now, let's take one example for 57. If the number is 57, right? If the number is 57, don't worry about the last digit, which is 7. Take the reverse of 5, which is 5. Now, the original number is 57. The reverse is 5. Take the concatenation of these two numbers, 5, 7 and 5. This will be 5, 7, 5. So using 57, you can create a palindrome number 575 of 3 digits. So the simple formula is, let us say your number in string format, because we are going to reverse it, so it will be easy in string format. But let us say whatever is your number, let us say the number is s. So to generate the even length palindrome number, it is very simple. S plus reverse of s. Now this is how we find a reverse in Python. So s plus reverse of s is going to be a even length palindrome number using s. Now for odd length palindrome number, the process is a bit different. What you do is, let us say the number is 57543. That's your s. Okay. You want to generate odd length palindrome number. So for 57543, the indexes in reverse order are -1, -2, -3, -4, -5. So the formula of odd length palindrome number is this one, which is s plus s of start from -2, go up to the last and go in the -1, that is reverse order. So start from -2, this is the -2 index, go in the reverse order. So the numbers are going to be 4, 5, 7, 5, 4, 5, 7, 5. And the odd length palindrome number is going to be the original number s, 57543, plus the reverse number 4575. So it will be 57543, 4575. That's the palindrome number you need. Now, I know that this is a bit tricky to understand, but once you understand the process of generating the palindrome number, this can be applied in some other questions as well. Now that's the complete approach of solving this particular question. Let me take you back to the code editor and let me try to explain you the solution in Python. So first of all, we are going to create two variables, result equal to 0, count equal to 0. Now the length equal to 1 means we want to generate one length palindrome number. After we generate one length palindrome number, and if we need more k-mirror numbers, we are going to generate 2 length, 3 length, 4 length. So this is that variable to track the current length palindrome number. Now while the count is less than n, right now the value of count is 0, we need to find n k-mirror numbers. So we will say while the count is less than n, half length is equal to length plus 1 divided by 2. That's the formula. The starting range is 10 is to power half length minus 1 and ending range is 10 is to power half length. Now it should be -1, but in Python, when you run a loop from start to end using for loop, so the end is already not included. So that's why I'm not including the -1 here, right? Now, once you have the start and ending range, you will just run the loop for left in the range of start to end. Convert your current number to a string so that it is easy to reverse it. Now, if the length required, that's the length, that is what length palindrome you need to create. If the length mod 2 is 0, it means it is an even number. That is, you need to create even length palindrome. So you will say pal is equal to int of s plus s reverse. That is completely reverse the number. Since this is a string, you can do the reverse, then convert it back to integer. Else, let us say this is odd, that is length is odd. In this case, pal will be, that is the palindrome number will be int of s plus s of starting from -2, that is don't include the last digit, then take the reverse of it. This is your palindrome number. Now we have created a function is palindrome base k pal. Now this function is going to check if my current palindromic number when converted to base k is also a palindrome number or not. And if it is, then this is going to say result is equal to result plus the current palindromic number, and then we can say count is count plus 1. And the moment we see that if the count is n, that is we got the n number of k-mirror numbers, we can directly say return the value of result. And if we are not able to find out n k-mirror numbers, then we are going to say length plus equal to 1. That is, then we will search for 2 length palindrome number, then 3 length palindrome number, 4 length palindrome number. This is going to be the logic. Now the last thing is understand about this function is palindrome base k. This is very simple. We have the function here def is palindrome base k. Whatever the number we receive, we are going to say digits is equal to a list. While the number is more than 0, you append num mod k. That is, take the mod of the current number with k. Then you can divide the number num with k. And the loop is going to end when the number becomes 0. Now we can say return digits equal to digits reversed. So basically this function is going to first convert our number into a base k number, store it as a list in digits, and then it is going to return true or false if this digits is a palindrome or not. So return digits equal to digits reverse. So that's the complete code for this particular problem. Let me just scroll a bit so that you can see the complete code. You can pause the video and see the complete code. Now let me just submit this particular code, and this is going to pass all the test cases, and this is a very efficient solution for this particular problem as well. So you can see the runtime is good, the memory is just fine. So I think this is a pretty efficient solution for this one. And guys, I have not followed the editorial. The editorial was using the binary search logic. I didn't found it very helpful, and the second solution in the editorial was very dumb. So I don't know how that editorial is designed, but that's fine. We have solved this particular problem by generating the palindromes, and I hope this video explains you the problem the solution approach, the thought process behind solving this problem as well. And if it did, then make sure that you hit that like button. And honestly, to create this video, it took a lots and lots of efforts. So make sure that you hit that subscribe button as well. And I will see you guys. I want to see you guys in the next video as well. So make sure that you do subscribe to the channel. And thank you for watching this video, guys.